Okay, in example 2, let's go ahead and try direct substitution and see what happens. So we're going to evaluate this limit as x approaches 0 of the quantity 4x squared minus 5x all divided by x. So we'll substitute 0 for our x in the numerator, and we'll substitute 0 for the x in the denominator, and we get 0 divided by 0, which that is an indeterminate form. An indeterminate form means that we're not able to determine the limit in that form. So when that happens and you have a rational function, if there's a polynomial that will factor in either the numerator and or the denominator, then you're going to go ahead and factor that and then cancel any common factors. Then you can try direct substitution again. So in our numerator, we have 4x squared minus 5x, that's a quadratic binomial, and there's a greatest common factor of x in both terms of that numerator. So let's factor out that GCF, and that'll give us the limit as x approaches 0 of x times the quantity 4x minus 5 in the numerator, and we still have an x in the denominator. Now we can see those common factors of x are going to cancel, and we can evaluate the limit as x approaches 0 of this linear function 4x minus 5 when we cancel out that common factor of x. Remember from our unit on rational functions that when you cancel a common factor like that, it creates a hole in the graph. So now we know our graph would have a straight line, or sorry, a diagonal line rather, with a hole in it at x equals 0. So now as we approach that hole from the left and the right side, we can find the value we're approaching by direct substitution. So 4 times 0 minus 5 is equal to negative 5. Okay, we can check that graphically in the calculator if we go to the y equals, and we're going to put in our original function, 4x squared minus 5x in the numerator, x in the denominator, zoom 6. There's our diagonal line, and there should be a hole at 0, so we'll press trace, type 0 for x, and there we see y is undefined when x is 0. That's the hole. And if we change our dimensions for the table setup, let's have our table start at negative 1, and we're going to change the table in increments of, let's do 0.05. Well, actually, let's do 0.01. That'll give us even a little bit more detail. And then we'll take a look at that table. And we can see at negative 1, right, we're all the way out at negative 9. Now we're going to get closer and closer to 0. And it's going down, down, down. There's negative 6. And here we're getting really close to 0. Look, we're at negative 5.3, negative 5.2, negative 5.08, negative 5.04, and then we hit an error. That's the hole in the graph at x equals 0. So see how we're approaching negative 5 on the left side, and on the right side, right, on the right, coming from the right towards that hole at 0, we can see we're also approaching negative 5. Okay, in example B, we're going to look and see what would happen if we did direct substitution. So if I put negative 7, the value that my x is approaching in the limit, into the denominator for x, negative 7 plus 7 is 0. So I would be dividing by 0, and that would be an indeterminate form. So we're going to avoid that indeterminate form by factoring the numerator. So we're going to look for factors of a times c is negative 14, that add to equal b in the middle, which is 13, and that would be 14 and negative 1. Since the leading coefficient is 1, I'm going to factor this with a box to organize my factors. First term of my quadratic trinomial goes in the first box. The constant, the last term, goes in the last box, negative 7. And then my diagonal comes from my crisscross. So I'll have a 14x and a negative 1x. Now looking for the GCF across the top row, 2x squared, 14x have a 2x in common. The bottom row, negative x and negative 7 have a negative 1 in common. First column, 2x squared and negative x have an x in common. Second column, 14x and negative 7, they have a 7 in common. And so this is going to factor into the limit as x approaches negative 7. And then in the numerator, I've got a factor of 2x minus 1 and a factor of x plus 7. The denominator still has its original factor of x plus 7, and those factors are going to cancel, leaving me with the limit as x approaches negative 7 of 2x minus 1. And that would graph a diagonal line and a hole in the graph at x equals negative 7. So we'll find where that hole is approaching negative 7 here by substituting the negative 7 in for x with direct substitution. 2 times negative 7 is negative 14, minus 1 is a negative 15. And so the limit as x approaches negative 7 of the quantity 2x minus 1 is negative 15. Okay, you're going to pause the video and try example C on your own, and then you can resume when you're ready to go over that one together. Okay, so direct substitution, we would have 3 times negative 2 quantity cubed minus 6 times negative 2 squared minus 24 times negative 2, all divided by 3 times negative 2 squared plus 6 times a negative 2. So now we've got a negative 8 times 3 is negative 24. Then we have a positive 4 times negative 6 is another negative 24. Then a negative times a negative is a positive, 2 times 24, or 48. And that would be negative 48 plus 48, which is a 0 in the numerator. Then in the denominator, we've got a 4 times 3 is 12. 6 times negative 2 is negative 12. 12 minus 12 is 0, and there's our indeterminate form. So to factor, we're going to look for a greatest common factor in the numerator and denominator in this case of 3x. So I'm going to have the limit as x approaches negative 2, and then I'm going to factor that 3x from the numerator, leaving me with an x squared minus 2x minus 8, all divided by, and then again we'll factor a 3x from that quadratic binomial, and that'll be an x plus 2 in the denominator. So these common factors, 3x and 3x from the top and the bottom of the fraction, are going to cancel. But let's see if we can factor that numerator further. We'll have an x squared minus 2x minus 8 to factor. So factors of negative 8 that add to equal negative 2 are negative 4 and positive 2. So this will become the limit as x approaches -2. We're canceling out the common factor of 3x, and we'll have an x minus 4, x plus 2, all divided by x plus 2, and there's another common factor we can take out. So we'll be left with the limit as x approaches -2 of the linear function x minus 4. There are two holes in the graph this time, one at 0 and one at -2. Our limit is approaching the hole at -2, and we'll find that by substituting -2 directly in for our x. And that y value it's approaching is -6.